In this concept, we're going to talk about sequences. A sequence is a list of numbers in a particular order. Each number in a sequence is called a term. Okay? So 3, 4, 5, this is a sequence of 3 terms, consisting of 3 terms. And they have a particular order. In this case, it's the addition of 1, right, to each term. Right? So the next term after 3 is 4, which is 3 plus 1. The next term after 4 is 5, which is 4 plus 1, etc., etc. Okay? An arithmetic sequence is a sequence in which each term after the first term is found by adding a number called the common difference. Okay? Here's an example. Determine whether each sequence is arithmetic. So we have a sequence of 1, 3, 5, 7, 9. This is a sequence of, in this case, 5 terms, right? 1, 2, 3, 4, 5. This is considered, or this is designated as the first term. 1 in this case is the first term, and it's expressed as A1 with the symbol A1. And then A2 would be the second term, and then etc., etc., to the term, to the however many terms the sequence has. In this case, it's 5 terms, so this is A9 is A5, and yada 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 up to A sub n. Okay, however many numbers the sequence has. The common difference for the sequence above is 2. Now, why is it 2? Well, again, and we figure this out by testing the numbers, right? So we started with 1, and the next number is 3. How do you go from 1 to 3? Well, you add 2, right? And then from 3 to 5, how do you get from 3 to 5? You add 2. 5 to 7, you add 2. 7 to 9, you add 2, etc., etc. So as far as these numbers, as far as this sequence of numbers is concerned, the common difference is 2, the addition of 2. Okay? So the sequence is arithmetic. The nth term of an arithmetic sequence. The nth term of an arithmetic sequence with first term a sub 1 and common difference d is given by this equation. A sub n, which is the nth term, is equal to the initial term, the first term, starting term, right, plus the order of the nth term, right? So there's the term itself, the value of the term, and then there's what order this term happens to be within the sequence, right? So going back to this sequence, for example, 5 is the third term, a sub 3, right? So the value of a sub 3 in this sequence is 5, but the order of a sub 3 in this sequence is 3, right? So the order of 5 in this sequence is 3. It's the third term in the sequence, okay? So a sub 1 plus n, which is the order of the term, a sub n, minus 1 times d, which is the common difference, where n is any positive integer. Okay, so n can be any positive integer. It has to be a positive order. You cannot have an order of term minus 5, right? It has to be a positive integer because it describes the order of the terms. Let's look at an example. Find the 10th term of the arithmetic sequence as shown below. 14, 12, 10, 8, 6. So you'll notice that the common difference in this case is negative 2, and that's perfectly fine. The common difference could be positive or negative, meaning you can be adding terms, or you can be adding a value, the common difference, or you can be subtracting the common difference. So the value of the common difference could be positive or negative. But remember, I said the order of the terms is always a positive integer. Okay, the order being n. So here we have 14 minus 2 becomes 12, minus 2 becomes 10, minus 2 becomes 8, minus 2 becomes 6, etc., etc. So this is an arithmetic sequence. So we need to find the 10th term. So what do we have? So our equation up here. Let me keep it. Oops. Let me keep it in sight. A sub n equals a sub sub 1 times n minus 1 times d. So a sub 1, which is the first term, is just 14, right? D, the common difference, is negative 2. And then we can just rewrite our equation. So a sub n equals a sub 1 plus n minus 1 times d. Substitute the values for a sub 1 and d, which we have. So now we have a sub 10, right? Because we want the 10th term, right? 10th term is a sub 10 equals a sub 1, the first term, 14, and then plus n, which is 10, the 10th term, right? Has order 10 in the sequence, minus 1 times negative 2, which is the common difference. Okay, so a sub 10 equals 14, and then 10 minus 1 is 9, times negative 2 is negative 18. 14 minus negative 18 is minus 4. Okay, so the 10th term is minus 4. A sub 10 is minus 4. Okay, so another example is that a sequence can be written as a function whose domain is the set of positive integers. Okay. Write an equation for the nth term of the sequence. So here we have our equation that we presented, right? And we may have the first term, for example, but we need a general equation for the sequence, so we can find any term, right? Maybe we don't have it. Here we have our general equation, but again, it's not optimized for this sequence, or it's not suited for this sequence. We have to find the values of d, n, a sub 1, etc. Right? Well, for the nth term, actually, you wouldn't need the n, right? So essentially here we'd need a sub 1 and d. So our a sub 1 is 12 because it's the first term here. And then d, the common difference, is, well, 7, right? We can just test these numbers and we'll see that the difference between each two terms in the sequence is 7. So d is 7. Okay. So starting with our equation and then substituting the values for a sub 1 and d, we get a sub n equals 12 plus n minus 1 times 7. And then again, from this point on, we just need to simplify. So 12 plus 7n minus 7, right? I distributed this 7 into these parentheses. And then combining like terms, 12 minus 7 is 5, and then just 7n is 7n. Okay? So a sub n is 7n plus 5. Okay? And essentially, it works like a function, right? We can consider it a function, f of n, where n is the order of the term in the sequence. So if you plug in, for example, 5, right? If you want, that gives you the fifth term in the sequence, right? Because you plug in 5 here, and then that gives you the actual 5th term. To find the 10th term in the sequence, we just plug 10 into the equation. Again, like I said, it works like a function. So f of 10 equals 7 times 10 plus 5 equals 75. Okay. The terms between any two non-successive terms of an arithmetic sequence are called arithmetic means. Okay, non-successive terms. Here's an example. Find the arithmetic means of the sequence 55 and then some missing term another missing term, a third missing term, and 115. So we know that there's 3 terms between 55 and 115 in this sequence, which starts at 55 and ends at 115. Or at least the terms that were given start at 55 and end at 115, and there are 3 terms in the middle. So to find these terms, what we need to do is to determine the common difference, right? So we can just then add it here or subtract it from here and then just get, the terms in the middle. So we determine a sub 1, right? Because we have our general equation, right? A sub n equals a sub 1, plus n minus 1 times d, right? We determine a sub 1 to be 55. N in this case is equal to 5. And why is that? Well, because we're going to use 115 as an example. So a sub 1 is 55, that's always useful, right? That's just constant to our, it's essential, to our general equation. But then the n and the a sub n can just be plugged in from any number or term in the sequence. But then d is what we need to determine. So we're going to use 55 for a sub 1, and we have 115, which we can use our as our a sub n, in which case it would be a sub 5 because it's the 5th term, and also in which case n would equal 5, right? Right? So a5 here is just 115. So that's exactly what we have here. 115 equals 55 plus 5 minus 1d, which is 4d. So d equals 15. So the common difference is equal to 15. So now we can find the required means by successively adding the value of d, the common difference, to the value of a sub 1 as shown to the right. So starting from 55, we add d. So 55 plus 15 is 70. Plus 15 is 85. Plus 15 is 100. And then plus 15 is 115, as we actually had starting off. Okay. All right. So the terms 70, 85, and 100 are the 3 arithmetic means between 55 and 115. Okay. And here we have some exercises. Please pause the video, work on these, and come back for the solutions. Okay, first exercise is write the equation for the sequence 5, 8, 11, 14, 17, etc. Okay, and again, we just have to observe how the numbers evolve, right? How each number is related to the previous number and the next number. So how do you go from 5 to 8? Well, you add 3, right? Add 3. How do you go from 8 to 11? Well, you add another 3. How do you go from 11 to 14? Well, you still add 3, right? 14 to 17 plus 3, etc., etc. So our common difference is 3, right? Plus 3. And what is our first term? A sub 1 is 5, right? So we have d and we have a sub 1. We can just write our general equation for the sequence. A sub n equals a sub 1, which is 5, plus n minus 1. Why did we leave n as n? Well, again, because this is the general equation for the sequence, which would allow us to determine any term in the sequence by just plugging in its order, the order of that term. Okay, so a sub n equals 5 plus n minus 1 times d, which is 3, times 3. Right, or I can just have it in parentheses. Okay. Okay, and this is my equation for the sequence. Of course, I can simplify, right? So I'll have, 5 plus 3n minus 3. So 5 minus 3 is 2, so I have 3n minus 2. So a sub n equals 3n minus 2. Okay, next exercise. Find the first 5 terms of the sequence described below. So we are told that the first term in the sequence is 2 and the common difference is 5. Well, that's very easy, right? So in this case, we just take the first term, so 2, and then just keep adding 5. So 2 plus 5 is 7. So the second term is 7. And then 7 plus 5 is 12. The third term is 12, right? And then 12 plus 5 is 17. So the fourth term is 17. And then the fifth term is 17 plus 5, which is just 22. Okay. Last exercise, find the arithmetic means of the following sequence. So we have 6, we have some missing term, another missing term, a third missing term, and 34. So we can just write our knowns, right, which are a1 equaling 6, we know that. And then we can just try to write our general equation, a sub n equals 6 times n minus 1 times d. Okay, so we don't know d, but we know that the fifth term is 34, and the first term is 6, and there are 3 terms in the middle. So we know that a sub n being, we know that a sub 5 is 34. So we know at index 5, right, our a sub n is equal to 34. So what we could do is we could just plug in, right, so we have a sub 5 equaling 34 equals 6 times 5 minus 1 times d, and now we can actually solve for d, right? And then once we solve for d, then we can find these missing means. So d equals, so 5 minus 1, sorry, this is 6 plus, yeah. So 5 minus 1 is 4d, right? So, and this is plus 6, we can subtract 6's on both sides. So 34 minus 6 over 4, right? Which is equal to 7. Okay, so we need a sub 2 equals, so add 7 to a sub 1. So 6 plus 7 gives you 13. And we need a sub 3. So add 7 to a sub 2. So 13 plus 7 is 20. And then we have a sub 4 equals 20 plus 7 is just 27. Okay? And now we found our means through the process shown. All right? This is it for this concept. See you in the next video.